which is graph. So what is a graph? Basically, a graph consists of a pair of vertices, of a set of vertices and a set of edges, right? So here, these points that you see are known as the vertices. Like V5 is a vertex over here, V4 is a vertex here, V3 is a vertex here, V1 is a vertex here, V2 is a vertex here. So all the vertices are represented as points as shown in this diagram. Then, as I said, a graph has a set of edges. So what are the edges? Edges are those lines which are connecting two vertices. So basically edges are always associated with a pair of vertices. Like here you can see that edge E7 is connecting the vertex V4 and vertex V5. So basically edge E7 is associated with the vertex pair V4 and V5. Similarly, E2 is associated with the vertex pair E2 and V2 and V4. So a graph basically consists of a set of edges and a set of vertices. Vertices are represented as points and the edges are represented as lines, segments connecting those points, right? So this is the basic concept of a graph. Now here you can see in the entire graph, everywhere an edge is associated with a pair of vertices or an edge is associated with two vertices. But it may happen that an edge may be associated with just one vertex, or in other words, it may just have one vertex as both its endpoints. Like here in case of edge E1, you can see it is associated only with a single vertex, which is vertex V2. That means it has V2 as both its endpoints. So such an edge is known as a self loop. Why? Right? So here you can see also visually it appears like a loop. So such an edge which is associated with a single vertex or such an edge which has a single vertex as both its endpoints is known as a self loop. Also, if two edges, that means more than one edge is associated with the same pair of vertices. Like here in case of vertex V1 and V3, you can see that edge E4 is associated with the vertex V1 and V3. Then also edge E5 is associated with the vertex V1 and V3. So basically E4 and E5, both the edges are associated with the same pair of vertices V1 and V3. Such edges are known as parallel edges. So any two edges which are associated with the same pair of vertices are known as parallel edges. And a graph which does not have either self loops or parallel edges is known as a simple graph. Now while drawing a graph, the shape of the lines or the length of the lines, whether you draw a curve or a straight line, whether you draw a short line or a long line, that has no significance. What is important is the incidence of the vertices and the edges. That means which edge is incident on which pair of vertices, that is important. Now visually you may find that if I call it figure 1 and if I call it figure 2. So visually you may find figure 1 and figure 2 to be two different graphs. But they are not. Why? Because as I said that the shape and size of the lines does not matter. What matters is the incidence between the edges and the vertices. And here if you notice, the incidence between the edges and the vertices is same. Let's see, like you can see that if I call this edge A, so edge A is associated with both vertex 1 and 4. Right? Similarly, here also edge A is associated with vertex 1 and 4. Then if I call this particular edge B you can see is associated with vertex 1 and 2. Edge B here is also associated with the vertex 1 and 2. If I call this edge C, so edge C is clearly associated with the vertex 2 and 4. And edge C here also is associated with the vertex 2 and 4. Then, if I call it vertex edge D, so you can see edge D is associated with the vertex 2 and 3, and edge D here also is associated with the vertex 2 and 3. Then if I call this edge E, so you can see that edge E is associated with the vertex 3 and 4, and here also edge E is associated with the vertex 3 and 4. So basically the incidence of all the edges and the vertices in both these graphs is same. Hence these graphs are called similar graphs, or they are the same graphs. Okay, so moving on, now we will see that in the diagram of a graph, if two edges intersect and if they do not cross a vertex or a point, see these points in this graph are representing the vertices. So if the edges are not intersecting at a particular vertex or at a point, in other words, then they are thought of as being in different planes, right? So this point of intersection, this thing you cannot consider a vertex. This is not a vertex, this is not a point. Alright, so vertices are given separately in the graph, and if the edges are intersecting somewhere at a point which is not a vertex, then it will not be considered a point or a vertex. Those two edges will not be considered in the same plane, they will be considered in a different plane, right? So intersecting does not mean a vertex. So a point where two edges intersect does not mean that it is a vertex, right? Okay, now we will see finite and infinite graphs. Now it's quite clear from the name itself what is finite. Something which is countable is finite, and what is infinite? Something which is not countable is infinite. So similarly in case of graphs also, if you can keep a count, or if you can count the number of edges and vertices in a graph, obviously it is a finite graph. And if you cannot count the number of vertices and edges in a graph, then obviously it is an infinite graph. Like here you can see two different portions of infinite graphs. It is not possible here to keep a track of where the edges and vertices would be ending. You cannot find out where exactly the vertices and edges of these two portions of two infinite graphs would be ending. Hence, you cannot count the number of edges and vertices that you have in these two portions of infinite graphs. Therefore, they are known as infinite graphs. So, this is all for the video today.